Welcome back to another video, and this video is on classes. Classes are fundamental to object-oriented programming languages including Python. Classes promote the reuse of code, so not having to repeatedly create the same code, and they provide a clear structure for your program. Classes are also very easy to build upon when needed, so it's very easy to build upon the class and add more methods when you need more functionality. An object is an instance of a class, and object-oriented programming helps with the idea of abstracting real-world objects and how we would represent them in code. For example, a real-world object could be a car, a house, a laptop, an apple, a bank account, absolutely anything, and bringing that idea and representing it as an object into the world of programming. And classes provide the blueprint on how to create these objects. So like a blueprint, a class describes how you create an object. However, the class is not an object itself. It's just a blueprint on how to create an object. For example, imagine a blueprint on how to create cars, and you use it to create these cars, and you create instances of these cars with the blueprint. So more than one car. And these cars, of course, do not have to be the same. That's the whole point of instances. So the general construction is the same. They are cars, but certain things are different. It could be the make and model, or it could be features, could be the engine size, the fuel it takes, etc. But they were all built using the same design pattern given by the class, the blueprints. These classes are actually a custom data type, so you are creating a custom data type or a template for creating objects. Although we have the built-in data types such as numbers, strings, lists, tuples, dictionaries, you may need custom types as well when working with complex ideas to model things in the real world. And working with classes is a very deep topic of its own. You can create very complex objects. So we have seen the different data types assigned to variables. When we create variables, for example, integer values that work with whole numbers and strings that are referred to as text values. And this has an impact on how the rest of the program works, because you're able to do mathematical operations on integer values, for example. For example, 2 plus 3 will give you 5. However, if the value 2 and 3 are interpreted by Python as string data types, Python will concatenate them together. So 2 plus 3 will give you 23. And with classes, you're able to create your own custom data types. And the whole point of classes and what makes classes different from functions is that you can create instances of these classes. For example, lots of different types of cars that are represented by unique objects. So in the slide I have here two unique objects, car1 and car2. We'll be creating these very shortly. And these two objects are created using the blueprints or the construction of the class, which we have defined over here. So a class is made up of attributes and methods. The attribute, or you can see this as the state of the class, is defined using variables, and its actions or behaviors, or what the class does, is defined using methods. So the class is made up using attributes and methods. Attributes is the state of the class, and the methods is what the class does. And we can see the class cars. Here is the attributes. So this is the variables, the state of the class. We can see make, model, fuel type, gearbox, colour and mileage. And then at the bottom we can see two car objects created. So these are the instances created using the blueprint or the construction of the class. So these two objects, car1 and car2, although they are different, one's an Audi A4, the other one's a BMW 4 Series. They are both unique, but they have been created using the blueprints of the class. And then we have one single method defined here. Of course, you can create as many as you like, and we will create another one in Python as well. By the way, this code will make a lot more sense once we have created it in Python, which we will do next. So we are in PyCharm, and you define a class with the keyword class, and then we specify the name of the class. We will call it cars, followed by open and close parentheses, and then followed by a colon. And a colon, of course, just like functions, indicates the start of a block of code. So when I press enter, so here the cursor needs to be indented, and here is where we define our code for the class. By the way, for variables and functions, we always use lowercase letters and underscores to separate each word. But for classes, we use uppercase and uppercase for the first letter of each word. We don't use underscores. It's just the convention and the way it has been for classes. Now before we start to build our code, let's say we wanted a placeholder for the class cars in our code. So we had no code to define here and it's empty. Other than creating the class itself with the class cars, if we run the file we receive an error because it's expecting a block of code. So to get around this error, Python lets you use the keyword pass. And this is like the temporary placeholder when you are yet to create your block of code. So now if we run the file, we don't receive any errors. So your code can continue without any issues and you have that placeholder there for you to create your class as well. But we are going to create some code. So let's define our function. And the way we do that is with the define keyword, def. And next we will use the init method, which is the initialize method. So that is a double underscore init followed by another double underscore. And we can see PyCharm has found it. So if we double click it, PyCharm has completed the rest of it. So you need to open and close parentheses. And inside the parentheses, we specify our parameters. And every function inside a class needs the self keyword as a parameter within the parentheses. The self parameter must always be the first parameter of any class function. And you don't have to call it self. You can rename it if you wanted to. But it's called self and it's best practice to leave it as it is. And self is just a reference to the instance being created. It represents the object it is building. For example, the cars Audi and BMW. BMW is a different instance of the car class than the Audi is, which Python knows about because of the self parameter. And the initialize method here. This method is to assign values to object properties in order to create the object in the way we want to create it. And this method is called upon every time a new instance is created. So it's needed. It's like a constructor. A constructor, by the way, is a special type of function called to create an object. And this is a method that initializes a newly created object. Otherwise, we would have to create the objects manually. So just see it as it's needed to create new objects. Now we will create our instance variables, also known as the attributes. These variables are called attributes or instance variables, and each of the objects usually has their own unique values assigned to them. So there is something else as well, it's called class variables, which we'll have a look at shortly. But these down here are called instance variables or attributes. And we need to create the variable starting with the keyword self again, so it knows about the object it is referring to or building. And as part of the parameters, including self, which is the very first one, we need to specify the rest of the parameters. So in our case, because we are creating cars, we will have make, model, fuel type, gearbox, color, and mileage. Now, if we press enter, next we will create our attributes. And I've missed the parameter color, so I'll add that in there as well. So we can see our attributes are matching our parameter arguments in here. So we've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And this all proceeds with the keyword of self before it. So it knows about the object it is referring to or building. So our cars will consist of unique values for the make, model, fuel type, gearbox, color, and mileage. And this will form our instances for a particular car represented by the instance object. By the way, this is not code that is running. Just like a function, this is code that we define. This is the blueprint which we will create our instances from. So next, what we will do is create two instances. The first one will be car 1, and we can see it's called Audi A4. It's diesel, automatic, it's grey in colour, and its mileage, it's done 20,000 miles. And the next instance we will paste in is car 2. And we can see how these are created. So this is a variable name, car underscore 2. So the variable will equal cars, the name of the class, as it matches the name here, class cars, followed by open and close parentheses, and then we specify our actual arguments, and these have to match the amount of times we have parameters for, and we do not need to specify the self keyword here, so it's just the arguments for all the parameters excluding self. So make, model, fuel type, gearbox, color, mileage, that's 1, 2, 3, 4, 5, 6, and we need 6 arguments, so 1, 2, 3, 4, 5, 6. And it's always good to make sure the file runs without error, so let's run the file. So far so good, there's nothing to output, but there's no errors. Actually, we do have something to print. Let's print both cars to the screen, just to verify they are both unique object instances, and we can see both have unique locations in memory assigned to them. So next, let's print something. So let's create a method to print the make of the car and the mileage it has done. So we can see we are calling our method miles. We are again using the self keyword inside the parenthesis, followed by a colon, which indicates the start of a block of code. And our block of code is to print this self.make. So we can see we are using our attribute make from over here, has done self.mileage. And we can see we are using the mileage attribute we've created down here. And what do we do to make use of our function? Well, first let's use car2, car underscore 2. And here's a key bit. So if I use the dot notation here, we can see the methods or the functions we can use. Now if we have a look, we've got mileage, make, gearbox, model, color, and fuel type is down here as well. And if you can see, we do not have miles. We should have miles, and that's because I can see from here our indentation is a little bit off. So we just need to bring that back and this print statement back as well. And now let's have a look again, dot notation here. And now we can see the method for miles. So let's double click miles and run the file. And we can see it says this BMW has done 40,000 miles. We can also create something called class variables and give them a default value. So this is known as a variable of the class that is shared by all instances. And it's declared inside the class, but outside of where we declare our instance variables. So it sits in between. So let's say, for example, all our cars will have satellite navigation, regardless of the car. So this is like a default value that would be the same for all our instances. So anything shared, we create over here. So this is known as a variable of the class that is shared by all instances. And as we can see, it's declared inside the class, but outside of where we declare our instance variables. So where we declare these are our instance variables, which are usually unique depending on our values down here. But this class variable is shared by all our instance objects. The reason I have created this is in case we want to override it. So we can do that. For example, let's say car 1 has two features. It has a sat nav and it has a sunroof as well. So down here we can do car underscore 1 dot feature. Let's add heated seats in there as well. So it has 3 extra features, does this car. Now just to confirm that has worked, what we do is print and inside parentheses car underscore 1 dot feature, and let's run the file. Now we can see car 1 has specified sat nav, sunroof and heated seat. And to make sure this is only applicable to car 1, because if we look, we specified car 1 here, car underscore 1 dot feature. Let's print car 2 and run the file again. So there we go, car 2 only has the satellite navigation. So that's a quick overview of class variables versus instance variables. By the way, we can also use formatted strings and format things out better. So the spec of this car is, and we can specify all our arguments. And then if we run the file, we can see that here, the spec of this car is, and then the details of the car. And of course, car 1 has all the extra features, sat nav, sunroof and heated seats. Now let's build on this class one more time and add another method. Let's say we wanted to have some method to increase the mileage every time the miles increase. In fact, let's create a new instance for this, car 3, and add the miles as a number rather than a string, without the quotes, so we can do some real mathematical operations on numbers, not strings, unlike car 1 and car 2. So let's paste car 3 here, and we can see car 3 has 50,000 miles, and it's without the quotes. So Python has interpreted this as an integer value and not a string like the other two. Now let's create a method which will add 2,000 miles onto the current mileage. We'll paste that below the first method and fix the indentation. So this one is called increase underscore miles. Again, we have the self keyword in there, followed by a colon. And now what we are saying is self.mileage, which is here as an attribute. We will add 2,000 miles. Or we could have done times 2 or times 3 to double or treble the mileage, etc. But in our example, we just want to add 2,000 miles to the current mileage. And if you watched my function video on the return statement, it needs to return the result of the function. So we need to specify self.mileage here, otherwise it will not print anything. And now what we can do is print. So this will be for car 3, And if we hit the dot notation, we can see our options. And we see the new method of increase_miles. So let's double click that one. And now we can run the file. We should see 52,000 miles. And that's it for this video. That's a high level overview of classes. So just to recap, we give the class a name and then we can specify our class variables. We create the main blueprint for the main body of the class down here and our parameters inside here. Not to forget the self keyword is the first keyword inside the parameters and it represents the object it is building. And of course the special dunder method, which is initialize with the double underscore before and after. And this initialize function is called upon every time a new instance is created. It is also known as a constructor, which is a special type of function called to create objects. And then further down below we can create our own methods. So I've got two very simple methods here. And down here is our instance objects. So we have created 3 instances of 3 cars.